Hey guys, so today we're going to be talking about the kinetic molecular theory. So this is really important when we're talking about gases because we have to keep in mind a few basic principles in order to fully understand how gases can behave. So the word kinetic refers to motion, as I'm sure you're pretty well aware. Kinetic energy is the energy of motion. The kinetic molecular theory makes assumptions about three different things: the size of gas particles, the motion of gas particles, and the amount of energy that those gas particles contain. So we have to think about all three of those things whenever we're thinking about how gases can behave. So the first postulate or rule of the kinetic molecular theory is that according to the kinetic molecular theory, or KMT, all matter is made up of tiny particles that are in constant random motion. This is going to mean that they're going to move in a straight line until they collide or bounce into something else, meaning another particle, the walls of the container, something that is made up of matter. So they're just going to keep going in a straight line until they hit something else and then bounce off, kind of like a bumper car. So that's the first part of the kinetic molecular theory, is that they are in constant random motion. The second part of the kinetic molecular theory is that the gas particles are a lot smaller than the space in between them. Most of a gas is made up of empty space. The particles are very far apart from each other. They're not touching at all. So, since they are so far apart, all the gravity, attractive forces, things that would normally make a gas stick together don't apply. So these particles are not going to be getting together. They're not going to be congregating. So that means that the motion of one particle of gas is totally independent of the motion of all other particles of gas. They are not interacting in any way except for when they bounce off of each other. The third postulate of the kinetic molecular theory is that no kinetic energy is lost when those particles collide. It's a completely elastic collision. That means that just like in a bumper car, when they bounce off, they're going to keep going. Another analogy would be one of those super bouncy balls that just keeps bouncing all over the place till somebody finally has to go and catch it. Okay, so that's called an elastic collision. When that occurs, no energy is lost. It just keeps going on and on and on. So since it's an elastic collision, no energy is lost. That means that the total amount of energy remains constant. That means whatever we start out with, we're going to end with that same amount. The fourth part of the kinetic molecular theory is a little bit new. This one says that all gases have the same average kinetic energy at a given temperature. So if you know the definition of temperature, that can make sense. Temperature is just a measure of the kinetic energy of particles in a sample of matter, which means that if I have a sample of gas at 35 degrees Celsius, it's going to have the same amount of energy as another sample of gas at 35 degrees Celsius. Doesn't matter if it's oxygen, nitrogen, mixture of air, doesn't matter. As long as it's the same temperature, it's going to have the same amount of energy. We also know that kinetic energy and temperature are directly related. That means the higher the temperature, the more energy you have. So think of this like the more that you run, the hotter you get. So the lowest temperature that we can possibly go is 0 Kelvin, and this has a special name called absolute zero. So absolute zero is the lowest point on any temperature scale that we have. We cannot go any lower than that. And to calculate kinetic energy, we have this equation right here: 1/2 mass times velocity squared. So again, for absolute zero, the greater the motion, the greater the temperature. If all motion stops, that means if every last atom stops moving, we're going to hit a theoretical number called absolute zero. So that's 0 Kelvin, or minus 273 degrees Celsius. This is impossible to reach. You can't take out all the